Hey guys, welcome back to another video, and today we're going to be solving the Leet code question for pigs. Alright, so I think this question is really interesting, so let's just kind of see how we can solve it, and before that, let's see what the question actually is. Alright, so we're given 1,000 buckets, and out of those 1,000 buckets, only one of them has some sort of poison inside of it, and everything else is going to be filled with water. Alright, so all of the buckets look the same. And if a pig drinks the poison bucket, it will die within 15 minutes. What is the minimum amount of pigs you need to figure out which bucket is poisonous within 1 hour? Answer this question and write an algorithm for the general case, okay? Alright, so the question here is, so this question over here, which we just read out, it's really specific, right? So we have 1,000 buckets, it will die in 15 minutes, and we have a total of 1 hour for testing, okay? So that's a more specific type of question, but now we'll just look at the general case, okay? So in the general case, if there are n buckets, okay, so that's the n number of buckets, and a pig drinking poison will die within m minutes. How many pigs x you need to figure out the poisonous bucket within p minutes? And again, in this case as well, there's only going to be one poisonous bucket, and we're guaranteed to have at least one. Okay, and only one, not at least. Okay. So a pig can be allowed to drink simultaneously on as many buckets as one would like, and the feeding takes no time. So this point is pretty important. The second point is after a pig has instantly finished drinking buckets, there has to be a cool down time of m minutes. During this time, only observation is allowed and no feedings at all. Okay. Any given bucket can be sampled an infinite number of times by an unlimited number of pigs. Okay, so hopefully you understand what the question is, and I would highly recommend to read it over and first understand what the question really is asking for. So now let's kind of draw it out and see how we can kind of visualize this question, okay? So we're going to be given 3 inputs, okay? So we're going to first be given the number of buckets we have. Then over here, we're going to be given a number, and this number over here is going to stand for the amount of time it takes for a pig to die, okay? So let's just call this minutes to die, okay? So this number is going to be how much time it takes to die. And over here, we're going to give one more number. And this number is the time we're given for making tests, right? So this is the number of the amount of time we're given to make a test. And by the ending of this time, whatever it is, we have to find out which bucket is poisonous. All right, perfect. And again, remember the end goal over here is to find the minimum pigs needed, okay? Minimum, remember that. All right, so for this case, let's just kind of standardize these two numbers. So let's say it takes 15 minutes for it to die. And let's say we have an hour for testing. So in other words, 60 minutes. Okay, so I'm just specifying the numbers so it's easier for us to calculate things. And let's just leave buckets as it is. All right, so let's kind of just go through this and see what is the total number of tests that we can make. So in the beginning, let's say we feed a pig, okay? So we fed a pig, and when do we know if something happens to it? So the next time we know something happens to the pig, given these conditions, since it takes 15 minutes for the pig to die, only after 15 minutes, we're going to find out whether it's alive or dead. All right, so we start off at 0, then we're going to be at 15 minutes, okay? Or we can just ignore 0. So at 15 minutes, we'll find out whether it's alive or dead. Now, the next time we can find that is going to be at 30 minutes. So 30 minutes is another time when we know it's alive or dead. Then we have 45 and then 60. All we're doing is we're just adding plus 15 between each of the intervals to see if it's alive or dead. All right, pretty simple. So as you can see, clearly we have a total of 4 tests that we can make. And another way to just find this, a really simple one, is take the total time we have for testing and divide it by the number of time or the amount of time we have before a pig dies. So in this case, 60 divided by 15 is going to be equal to 4. So over here, we're basically telling that we can make up to 4 tests. So now let's start off with the base condition, okay? So we'll just kind of build off of this, and you'll slowly understand how there's a small pattern which is actually really unique, and once you find it, it's really cool. Okay, so let's say the number of buckets we have in the beginning, or in this case right now, is going to be 4. All right, and let's just draw each of those buckets. So 1 bucket here, 2, 3, and 4. And I'm going to label them starting from 0. So 0, 1, 2, and 3. All right, so now we got 4 buckets. Now within these 4 buckets, 3 of them have water and 1 of them is going to be poisonous. So we don't know which one is poisonous, but we just want to try out. So in this case, let's say we have just 1 pig, okay? So let's say we have one pig. What we're going to do is we're going to have that pig go and eat whatever is at the 0th bucket. And let's say nothing happens, that means that it's still alive and 0 is filled with water. Then we're going to have that pig go and eat with the first bucket. Okay, so now it's going to eat at the first bucket, then it's going to eat at the second bucket, and then it's going to eat at the third bucket. So how many times did the same one pig eat a certain thing? So it ate once at 0, second time at 1, third time at 2, and for the fourth time at 3. So in total, we had the same pig eat 4 different buckets. And that is a total of 4 trials. So that actually makes sense because we can make a total of 4 tests. And by doing this, we make a test, and over here, we get the next results at 15 minutes. If it still doesn't die, we're going to go over here, and then we have 30 minutes. Then we go over here, then 45, and then over here, 60. So it is within our time frame of 1 hour. So this is a good approach. So now let's actually add one more condition, and let's see how that looks like. So let's say our buckets now is going to be equal to 5. So instead of 4, we have 5 buckets, and the minutes to die and the minutes to test are going to stay the same. And now let's draw a 5th bucket, okay? So let's draw a 5th bucket over here, and this over here is going to have an index of 4. So now we're going to do the same steps, okay? So now we're going to have the pig eat over here, over here, and over here as well. But now the problem is, after eating for a total of 4 times, we're going to be done with our time. We're going to be done with 1 hour. And technically, we're actually not supposed to cross that time period. So what exactly do we end up doing now? So now, using deduction, we can actually figure out something really simply. So let's say the pig eats at 0, nothing happens. Then it eats at 1, nothing happens. 2, nothing happens. 3, nothing happens. So far, 60 minutes have gone by and we're done with the testing period. But we did not test 4 yet. But pretty simply, we can just deduce that if the pig did not die in 0, 1, 2, or 3, that means that 4 is where the poison is. So in this case, we can take a maximum of 4 tests, which is 60 divided by 15. We can actually be doing 5 tests because if the 4 tests actually end up with a live pig, we know for a fact that the 5th one, or in this case, this over here, is going to be the one with poison. Alright, so hopefully you understand this condition. And now that you understand this, we can go on to a bigger number. And before that, let's just try to generalize the small part over here, okay? So let's say we are actually given 100 minutes and it takes 10 minutes for a pig to die. So 100 divided by 10, and 100 divided by 10 is going to give us a value of 10. So what this means is that let's say we have a row of 11 values, right? In one row, we have 11 buckets. So in that case, we can make up to 10 tests. And if all the 10 tests make the pig alive, that means that the 11th bucket has the poison. All right, so hopefully you just understand this part pretty well. Make sure you do understand it. And now let's just go on to a case where we have a lot more buckets. So we have 15 buckets, and now I'll draw it out. Okay, so this over here is the grid, which consists of a total of 15 buckets. So if you're wondering why there's only 14, it's because we're starting off at 0, okay? So 0 all the way to 14 is nothing else but 15 buckets. So now I want you to notice how many buckets are in a row. So in one row, we have 5 buckets, okay? So there's 5 buckets in each of our rows. And why exactly is that? And the reason for that is the same as what we saw earlier. And that is basically that we can check for 0, 1, 2, and 3. If we're alive in all of those, that means that 4 is the poisonous one, okay? Okay, so now you get that. And now let's see what exactly our procedure is going to be when we actually solve this question. So we can kind of split this question into 2 different parts. So one part is going to be to find out at what row is the poison actually there, okay? So this is just going to give us at which row. And another thing is going to give us at which column the poison actually is. Okay, and before doing all this, I just want to make 2 things really clear. So I'll just go back to our question here. So one thing that I want to make clear is the question is, what is the minimum amount of pigs you need to figure out whether the bucket is poisonous, okay? So over here, we do not care how many pigs die. For all we care, all the pigs could die, but as long as we find it with the least number of pigs possible, then we're good to go. So that's one thing you need to understand. And the other thing that you want to understand is the best condition in this case is you could just put the same number of pigs at each bucket, right? So in this case, you could put 1,000 pigs and each of them at one bucket, but obviously that would just take up 15 minutes, right? So that would be the fastest, right? Giving us an answer in 15 minutes. But the problem with that is that we would need 1,000 pigs, which is way too much and not needed, okay? So there's that. And finally, one last thing is this, okay? A pig can be allowed to drink simultaneously on as many buckets as possible. So we're going to kind of use that rule to solve whatever we are about to do right now, okay? So what we're going to do is we're going to take a pig, okay? And we're going to and for now, let's just focus on getting the correct row. So the pig is going to drink at 0, 1, 2, 3, and 4. So it's going to drink 0, 1, 2, 3, 4 at the same time, right? So in this case, if everything is water, then the pig is going to live. But if even one of them ends up being poisoned, then we know for a fact that the poison is in this row. Alright, so let's say 3 has the poison, okay? 3 has the poison. So the pig over here is going to end up dying. So we wouldn't know where exactly it is, but we would know that the pig or the poison, is going to be in this row. So that's exactly what we're doing. We're finding out at what row the poison is. So after drinking this, we would then make the pig drink 5, 6, 7, 8, and 9. So now in this case, we're going to drink this entire row. And finally, we're just going to do those two. We're not going to make it drink 10, 11, 12, 13, 14, because if the poison is not over here, right? So if this is all water, we know for a fact the poison is going to be in the last row. Okay, so now this is how we're going to get our row using one pig. Now, how exactly do we find our column? So for the column, we can do one thing. And the thing that we could do is after checking for the row, we could use that same pig and use it for the column. But that actually won't be good for us because it could possibly exceed 4 tests, and that's not good for us, right? So what we're going to do is over here, we're going to be using one pig, and over here, we're going to be using another pig. So a total of 2 pigs are going to be used. Perfect, okay? So now we have 2 pigs, and let's just look at this. So again, this is how we're finding the row. I already showed you. Now we're talking about the column, and the approach is similar, okay? So now we're going to make it go at 0, 5, 10, right? Like this. Then we're going to go make the pig drink 1, 6, and 11. Then we're going to make the pig drink 2, 7, 12. Let me just write these down quickly. So then 3, 8, and 13, and that's it. So over here, we have a maximum of 4 tests. So what's going to happen is the row and the column are going to be happening simultaneously. So what I mean by that is this step and this step are happening at the same time. Okay, and by the ending of this, we're going to find out at what row and what column the poison is. So let's say, just for a hypothetical, the pig actually dies by drinking 2, 7, and 12. So that means we know that somewhere over here we have poison, but we don't know on which row. But let's say the pig lives over here. It lives at 0, 1, 2, 3, 4. It also lives at 5, 6, 7, 8, 9. So in that case, if it lives in the first 2 rows, we know that it is not going to live on the 3rd row. So now we know that this over here is the row that we're looking for. So really simply, the intersection of these two is going to be our answer. And what is the intersection? Well, the intersection is at 12. So bucket number 12 has the poison, and we want our pig to stay away from that. And to do this, it only took us 2 steps. Now, let me try to generalize this. Again, remember, 2 steps is because we're taking 15 minutes to die and 60 minutes to test. All right, so now let's say we actually have a total of 25 buckets. Then in that case as well, we would only require 2 pigs. And why exactly is that? So in this case, if you look at it horizontally, we have 1, 2, 3, 4, 5, right? So we have 5 rows. And let's see how many columns we have. We only have 3 columns. So to get the most out of 2 pigs, it would be in a condition where we actually have 5 columns and 5 rows. So by having 5 by 5, which actually amounts to 25 buckets, we're going to get the best result using 2 pigs. In other words, we'll have the most efficiency. But after we go past 25, we cannot use 2 pigs anymore. We are going to need more than 2 pigs. Now, going back to this analogy that we're kind of making here, let's just say we have 5 pigs, okay? Or sorry, 5 buckets. So when you have 5 buckets, you only need 1 pig, okay? At 5 to the power of 1, that means that you only need 1 pig to find out where the poison is in 5 buckets. And over here, we have 5 to the power of 2. What that means is that we have 2 pigs for finding out where the poison is in 25. But how do we keep going, okay? And now, let's just say we have 125 pigs. So to do that, I'm just at Excel over here. And horizontally, we have, and one more thing is that remember that the timings are still the same, okay? We have 15 minutes to die and 16 minutes to test, or 1 hour, okay? So keeping that in mind, over here, we have a horizontal of 5 rows, but our vertical goes up to more than 5 rows. We have 25 rows vertically, and we have 5 columns, right? So if you kind of just look at this as it is, you could kind of imagine we could put 1 pig for finding the column, right? So that's pretty simple. But then on top of that, we would need 1 pig on this row, 1 pig on this row. So that's 2, then 3, then 4, then 5. So we would need 5 pigs plus 1. So we need a total of 6 pigs. But we kind of want to think of this outside of the box, right? So we're looking at this in a 2-dimensional way. But what if we add a 3rd dimensional to this? So in this case, when you have 3 dimensionals, you would have a cube. So what's going to happen is we're going to have one of the rows of buckets over here, right? So we would have 5 buckets in the x-axis, then we would have 5 buckets in the y-axis, and we would also have 5 buckets in the z-axis, okay? So that over there gives us a 5 by 5 by 5, okay? So let's just write that down. So when you have a 5 by 5 by 5, that gives you a value of 125. In other words, that's basically telling us that we need 3 pigs to find anything which is below or equal to 125 buckets, okay? So to find the poison which is equal to 125 buckets, we are going to require 3 pigs, okay? And this also results to anything which is less than this, but what is the lower bound for this going to be? Now again, remember when we had 2 pigs, we could go up to the number 25 buckets, okay? So we're gonna need 3 pigs whenever we have more than 25 buckets or less than or equal to 125 buckets. So hopefully you can kind of see the correlation here. Again, this is specific to 15 minutes to die and 60 minutes to test. And now we can generalize this using this kind of solution that we found out, which is basically given 15 minutes, we know that we can only take 4 tests. So we have 15 minutes to die and 60 minutes to test. So 60 divided by 15 gives us 4 tests. But we're adding 1 to this because of that extra case that we saw. So the first 4 are still alive. That means the 5th one is it. So in this case, we're adding 1. So that gives us 5. And now we're going to take 5 as our base. And in other words, to make it simpler, we're only going to be looking at base 5 numbers. So you could use logarithms to solve this. And we're going to be looking for the base 5 number. And we're going to keep adding on to our count until whatever our value is sits in between whatever this is. So let's say we have 100 pigs. So 100 pigs needs to be greater than 25, but less than 125 given these 2 conditions. So now let's try to generalize it. I tried my best to explain it. Hopefully it was good enough. So yeah, now let's try to code it out. Okay, so over here, what we're going to be having is we're going to have the number of pigs needed, okay? So the number of pigs needed in the very beginning, we're going to start off with a value of 0. So now what's going to happen is we're going to go inside of a while loop. Now, what we're going to do inside of this while loop over here is we're going to take the minutes to test, okay? And the reason we're taking the minutes to test is because we're doing a more generalized way, right? So take the minutes to test, and we're going to divide that by the minutes to die. And this is exactly the same as doing 60 divided by 15. Now, to this value, whatever this value is, we're going to end up adding 1. Now, the reason we're adding 1 is like I said earlier, right? So it's the exact same reason why we added 1 to 4, right? So 4 plus 1, 5, and that gives us 5 things that we could test, okay? So we have this over here. And now what we're going to do is we're going to raise this to the power of how many of our pigs we have. And this just goes back to the exact same thing which I said earlier. So whatever this number is, so in this case, when you have 15 minutes to die and 60 minutes to test, that means we're only looking at base 5 numbers. So 5 to the power of 0 would end up giving us a value of 1. So then we're going to increase. So then we're going to check against a condition. But each time what's going to happen is we're going to increase the number of pigs we have. then we're going to have 5 to the power of 1. So that is going to give us a total of 5 buckets, right? So we're going to keep doing this until whatever value we end up having here is less than how many other buckets we have. Now, the second this value over here becomes greater than the number of buckets we have, we're not going to go inside of this loop. So let's just actually look at a condition where the minutes to die is 15, then 60, and the number of buckets is 125. So first we're going to go inside of this, then we would have 5 to the power of 1, but we keep going, so then we would have 5 to the power of 2, giving us 25. And then when we have 5 to the power of 3, we would have 125. Now 125 is going to be equal to the number of buckets, which is 125. And in that case, our pigs becomes 3, and we're going to stop. So we're not going to go inside of the while loop. And at that point, we can just directly return the number of pigs we have. All right, so that should be it for the solution. And hopefully you did understand how this works. I thought the question was really interesting and it was a pretty fun question. So yeah, thanks a lot for watching, guys. Bye.